Let's take a look at this example. Please notice that we have voltage source and current sources. So what I would do first, I would convert this voltage source to the current source. So let me find IS1. IS1 is equal voltage source 1 over R1. This is equal 1.2 volts divided by R1, which is equal nothing else, just 220 ohms. So if I source 1 is equal 1.2 divided by 220 is equal 5.45 milliamps. Okay, so this is my I source 1. Next, I'm supposed to redraw the circuit, and because my positive terminal is at the top, I'm going to draw the current source with the arrow pointing up. So I have my resistor R1 over here. Okay, this is my resistor R1. This is going to be my second current source. Okay, and this is my resistor R2, and now we have I3, and we have the terminals XY, and of course voltmeter over here. Okay, so let's take a look what we got over here. This is I source 1. Now this is my ground. I'm going to consider these two currents as the positive ones, and this one is negative. So I total is equal I source 1 plus I2, this is my I2, and this is my I3, minus I3. So I total is equal I source 1 is equal 5.45 milliamps plus I2, which is equal 800 microamps, minus I3, which is equal 0.3 milliamps. Now we can use the calculator, and we have 5.45 exponent 3 negative plus 800 exponent 6 negative minus 0.3 exponent 3 negative. This is equal 5.95 milliamps. 5.95 milliamps. This is my I total. Next, I'm going to find total resistance. Because I have just two resistors and both of them are connected in parallel, okay, because as you can see, you know, the top terminals are connected together and bottom terminals are connected together. So it means that they are connected in parallel. So simply write that R total is equal R1 times R2 over R1 plus R2, where R1 is equal 220 ohms, because 0.22 kilo ohms is 220 ohms, times R2, which is equal 680 ohms, over 220 ohms plus 680 ohms, equals 220 times 680 equals, divide by, open parenthesis, 220 plus 680, close parenthesis, equals 166.22 ohms. Okay, this is my total resistance. So now we can redraw the circuit. And our circuit is going to look like this. We have current source, which is pointed up, and we have total resistance, and total resistance is equal 166.22 ohms, and I total is equal 5.95 milliamps. Okay, so if you want to find VXY, you can use you're supposed to use the Ohm's law. So this is I total times R total, because these are the terminals XY, so voltage across these two terminals is equal to the voltage across this resistor. So if you are going to find the voltage across this resistor, this is going to be the same voltage which the meter is going to measure. So I total we found is equal 5.95 milliamps times R total, which is equal 166.22 ohms. So VXY is equal 5.95 exponent 3 negative times 166.22 is equal 989 volts, millivolts. Okay, VXY is equal 989 millivolts. So now we're supposed to find I1, but we have to realize that we found already I1, because my I1 is nothing else, just my IS1. Okay, IS1. So I can say that I1 is equal IS1, and this is equal IS1 is equal 5.45 milliamps. So this is 5.45 milliamps. Okay, because we have I2, I3, so my first current source has to be labeled I1. I put IS1, but this is the same current, so IS1 is equal to I1, and this is equal to 5.45 milliamps. P2, okay, so P2, this is the power at resistor 2. You're supposed to realize that voltage across resistor R2 is equal to voltage Vx. Okay, voltage Vx, so voltage across these 2 points is going to be the same voltage across resistor R2. So P2 is equal to V2 to the second power over R2. In other words, this is VXY to the second power over R2. So VXY is equal to 989 millivolts to the second power over R2, which is equal to 680 ohms. This is equal P2. So I have 989 exponent 3 negative to the second power divided by 680 equals 1.43 milliwatts. 1.43 milliwatts. Okay, so this is my power P2, and if I want to find P total is equal VXY Vxy to the second power over R total. Vxy is equal 989 millivolts to the second power divided by R total 166.22 ohms. This is equal 989 exponent 3 negative to the second power divided by 166.22. This is equal 5.88 milliwatts. 5.88 milliwatts. So we found Vxy, we found I1, we found P2, we found P total. Okay, so we can say that the problem is solved.